forecasters are issuing an urgent hurricane warning. The details are frightening. Winds will top 400 miles per hour. The storm is 16,000 miles across. It will last for centuries. The good news, no cities are in danger because this storm is on the planet Jupiter.
Jupiter's Great Red Spot is more than a Category 20 hurricane.
It's 500 million miles away, but we can't help wondering what it would be like on Earth.
A storm on Earth with the intensity of the Great Red Spot would be truly devastating.
The water would pile up and would be several hundred feet deep.
And it would move on a storm track so slow, it would seem to last forever.
The storm would be there for a long, long time. It would not be a fun place to be.
Watch out. It's space weather at its worst. The biggest storm in the solar system. Earth's is just one kind of weather. On other planets, there are storms beyond the imagination, climates and conditions that we hope to never see on Earth. But could they happen here? And if so, could we survive deadliest space weather? The planet Jupiter is the monster of the solar system. Its mass is 2.5 times as much as all the other planets combined. The biggest planet in the neighborhood also has the biggest storm in the solar system. A mammoth hurricane-like system with 400-mile-per-hour winds, known as the Great Red Spot. What would happen if a storm with winds so strong appeared on Earth? It would be a day we hope never happens. Weather satellites pick up a freak hurricane in the open ocean. No hurricane on Earth has ever had winds faster than 200 miles per hour until now.
Hurricanes on Earth already do extensive damage. Well, think of one with 400-mile-an-hour winds. If you double the speed, that's actually 4 times the energy of these swirling particles. It would really cause a lot of damage.
In 2012, coastal cities in the U.S. were devastated by Superstorm Sandy. Any shorelines now directly in this bigger storm's path would face extreme danger. Sandy's effects would be dwarfed when the huge storm approaches land.
Like any hurricane coming in over the water, it would create a storm surge. It would pile up water ahead of it. You would see something that truly is terrifying. A giant wall of water heading towards you.
Some areas endured a 9-foot storm surge from Superstorm Sandy, but this storm could be more than 20 times worse. With the surge reaching 200 feet, many coastal towns would be completely underwater. Fortunately, the giant storm known as the Great Red Spot is about 500 million miles away, on Jupiter, the 5th planet from the Sun. Jupiter is the solar system's biggest planet, so big that 1,300 Earths would fit inside. It has 67 known moons. Its day is 10 hours long, and it takes 12 Earth years to go around the Sun. The planet is a giant ball of gas and liquid. Temperature registers a chilly 229 degrees below zero. The turbulent atmosphere is home to lightning strikes, helium rain, jet streams, and a planet-wide collection of swirling storms. Most of them are small for Jupiter, but one is a colossal giant. We call it the Great Red Spot.
The Great Red Spot is this enormous swirling storm in the southern hemisphere of Jupiter that's so large you could actually fit 2 Earths within it side by side. It's about 16,000 miles across from east to west, and about 8,000 miles across north to south.
On Earth, Swirling storms like this are known as hurricanes or typhoons. The largest ever was Typhoon Tip, which made landfall in Japan in 1979. It was nearly 1,400 miles across. Jupiter Spot covers 70 times as much area. The megastorm is also very old. The longest-lasting hurricane here at home was Typhoon John, surviving for 31 days in 1994. On Jupiter, the Great Red Spot has lasted 4,100 times longer and counting.
The Great Red Spot has been known for probably about 350 years.
Jupiter's superstorm was discovered by early astronomers in the 1660s.
It could be even longer than just the couple hundred years that we've seen it. We don't even know how long it's been there.
The Great Red Spot is usually compared to hurricanes on Earth because it's a circulating system, also known as a vortex. On Earth, hurricanes are rated on a scale of 1 to 5. 2005's Hurricane Katrina had peak winds of 175 miles an hour, putting it in Category 5, which includes anything 157 miles per hour or more. On Jupiter, a 1 to 5 hurricane scale just wouldn't be enough.
So if you compare these wind speeds on Jupiter's Great Red Spot to hurricanes on Earth, you would find that Jupiter's Great Red Spot is more than a Category 20 hurricane.
The Great Red Spot has been called a backwards hurricane, rotating in the opposite direction compared to storms on Earth.
The Great Red Spot is in Jupiter's southern hemisphere, and storms like hurricanes in Earth's southern hemisphere rotate in a clockwise fashion. This one rotates in a counterclockwise fashion.
Another thing backward about the Great Red Spot is that it is a high-pressure system. Hurricanes on Earth are all low-pressure systems. In Earth's low-pressure hurricanes, the fastest winds are near the center, surrounding the eye of the storm. The Great Red Spot, on the other hand, has its fastest winds around the outside edge. What if an earthly aircraft was caught up in the red spot's fastest wind, 400 miles per hour, in a belt 3,000 miles wide? The plane is a C-130 Hercules, the famous Air Force cargo plane fitted out for the hurricane hunters. Brave crews who fly into intense storms to get information for weathercasters.
You would think that an aircraft would be shredded by the winds of the Great Red Spot.
Around the periphery of the storm, the winds are very fast. They're 400 miles an hour, which is a good storm any way you look at it. In the center, though, it's quite calm.
It seems incredible, but the hurricane hunters would find that their aircraft would survive easily if it flew into the storm.
"400 miles an hour, especially 400 miles an hour with very low turbulence, well within the capability of the plane itself to handle, well within the capability of the pilots to handle. Plane flies at roughly 400 miles an hour. It can withstand that kind of wind easily. And in reality, aircraft are among the few structures that can.
The mysteries of Jupiter's Great Red Spot extend beyond its size and power. Scientists also puzzle over its age. What strange process keeps this monster vortex swirling for century after century?
It's like a selective cannibal that knows how to feed.
But what feeds the giant cannibal? And can it go on feasting forever? Jupiter's Great Red Spot is a high-speed storm with winds swirling around its edge at 400 miles per hour. It centers at 22 degrees latitude, south of Jupiter's equator and creeps slowly to the west. As big as it is, it covers only a small percentage of the giant planet's surface. Even so, a scaled-down Great Red Spot covering the same portion of the Earth's surface would still be a monster 1,450 miles across.
If the Earth had its own storm like the Great Red Spot, then it would center about 22 degrees south of the equator, over where Rio de Janeiro is today, for example. And the storm would be huge. It would be about as wide as South America is at that same latitude.
Rio's landscape is like a bowl, open to the sea. The storm surge here would push the floodwaters up against the surrounding mountains.
The water would pile up and would be several hundred feet deep for most of the 40 days it would take the storm to pass.
High above the city is the famous statue of Christ the Redeemer. 100 feet high, weighing 700 tons. Like other monuments and tall buildings, it's built to withstand winds no higher than 200 miles per hour.
The statue is made out of reinforced concrete. The relentless pressure of 400-mile-an-hour winds would loosen the statue from its base. The statue would probably fail all in one piece and come crashing and break up.
But of course, the Great Red Spot exists on Jupiter, not here. What has kept the giant vortex swirling for 350 years or longer?
One reason might be that the storm doesn't go over land the way hurricanes do on Earth. When hurricanes cross over land, they lose their energy and peter out.
Jupiter has no land surface at all. Even so, all of its swirling storms eventually dissipate. Only the Great Red Spot endures.
There's theories about what causes the red spot to be there. We do not quite understand it. But one theory is when you have two jet streams going by each other in opposite directions, eventually you get little wave patterns, and eventually you can turn into these wheels, these little gears that you get between the two streams that are flowing past each other. And that's the theory that most people are buying into these days.
But it might be that the Great Red Spot is like a monster that keeps spinning by eating smaller storms, unlucky enough to get too close.
Jupiter's Great Red Spot is almost like a living thing. It selectively swallows other vortices, smaller hurricanes, that have the same direction of rotation as it does. And it repels the vortices that have the different direction of rotation. So it's like a selective cannibal that knows how to feed, and it will feed as frequently as it needs to keep itself from dying.
But how long can it go on? It already shows signs of old age.
The Great Red Spot is not static. It's constantly changing, and it's in fact about half as big as it was even 100 years ago.
We think there is going to be a finite lifetime to the present red spot. In fact, in about the year 2040, well in the lifetimes of a lot of us, the red spot might just disappear.
Jupiter's atmosphere will churn on, hardly missing its giant storm, until another one generates. The Great Red Spot's future remains a mystery for now, but some scientists are hoping to make the strange storm reveal how it works by creating their own red spot, right inside the lab. The giant planet Jupiter is a place where there's one bad weather day after another. Below the colorful ammonia in the upper layer of Jupiter's clouds is a layer of water vapor, an ingredient for lightning storms.
In these storms, water droplets and ice particles rub against each other and collide with each other, and that makes them charged. So you get a positively charged part of the cloud and a negatively charged part of the cloud. That sets up a strong electric field, exactly what you need for giant lightning bolts to go from one to the other. And the electric fields are so strong that the lightning bolts are far more powerful than those on Earth.
There are 30 million lightning strikes, from 100,000 storms each year in the United States. At many times the power of our own lightning. Suppose a Jupiter-sized bolt struck electric lines on Earth. The grid might handle a single jolt, but a cluster of strikes would be different. Instead of a minor blackout like we're used to, the lightning storm might plunge an entire city like Chicago into total darkness. On Earth, thunderstorms can be up to 13 miles high with deep, complex structures. But from space, all we see of the Great Red Spot is its upper surface. And to figure out how it works, scientists need to look at its shape in 3 dimensions. Researchers in Los Angeles are doing that by creating 3D simulations. They work with simple tanks of fluid sitting on top of rotating turntables, which simulate the atmospheres of rotating planets.
Our rotating tank experiments have shown in a fairly simple system that rotation of a fluid naturally lead to the development of large-scale stable vortices, such as ones you see on the gas planets, like the Great Red Spot.
But Jupiter's atmosphere is stratified into layers. Up high, the gas is thin, and it gets denser and denser as you go deeper into the planet, until the crushing pressure of gravity turns it into liquid. There's no solid surface at all. Lab director Jonathan Arno assists as visiting professor Michael Labars demonstrates an unusual new experiment. In his tank, the fluid is stratified like Jupiter's layer cake.
We've made tanks of water where the densest fluid is at the bottom and the least dense is at the top.
This may be the first clear picture of what the 3-dimensional shape of the Great Red Spot looks like. Here in a rotating stratified tank. It develops in a matter of minutes. The simulated red spot settles into a flattened pancake shape. The Great Red Spot on Jupiter covers an expansive area, but is stretched incredibly thin, unlike the deeper hurricanes and thunderstorms on Earth, which extend down to the planet's surface. Simulating the Great Red Spot in the lab is no more than a first step in understanding how the storm works. Elsewhere, though, one of its secrets has just been cracked. After 350 years, we may finally know just what makes the Great Red Spot red. After watching Jupiter's Great Red Spot for up to 350 years, astronomers have discovered that it is a mammoth storm, surviving perhaps by gobbling up its innocent neighbors. Other smaller storms that happen to get in its path. And despite some of its mysteries being solved, one puzzle continues to nag us.
Why is the red spot red? This has been one of the most outstanding questions in all of planetary science.
On Earth, even the biggest hurricane is white when seen from space. Water, after all, reflects white light. So the Great Red Spot must be made of something else.
We have just done a laboratory experiment which we think really does answer the question.
At the Jet Propulsion Laboratory in California, scientists recently set out to find an answer to the centuries-old mystery.
These valves kind of slowly, but at the same time.
Dr. Robert Carlson and myself have been actually recreating Jupiter in the laboratory. We put in ammonia and a number of other gases trying to create the red spot. We've actually failed a number of times, and actually we created green spots at times instead of red spots, which surprised us.
But they weren't discouraged. And in October 2012, Carlson and Baines announced the first likely recipe for the red in Jupiter's giant storm. Working with compounds known to exist on Jupiter, they arrived at the secret combination. It starts with ammonia, like the ingredient in household cleaners. Then they added acetylene, the same gas used in a welding torch. Add ultraviolet light as the sun provides, and the two gases split up and recombined into complex compounds that look like a piece of Jupiter right in the lab.
That's a great match. You know what I want to say? I want to say eureka.
Carlson and Bain's combination of ammonia and acetylene converted into chemicals that match the color of the Great Red Spot almost exactly. The 350-year-old question now has an answer. For all its color, it's the size, speed, and longevity of the Great Red Spot that have captured our imagination and made us realize there is real weather in space.
We started wondering, what's the weather like on Jupiter? What's the weather like on Neptune? And that's what you would ask your friend on the East Coast if you were to call him up. What's the weather like over there?
The weather on Jupiter naturally makes us think of how it might feel if those kind of extremes ever happened on Earth. And while a Jupiter-sized storm on our own planet is impossible, we have our own version of superstorms, such as Hurricane Sandy, which showed that when it comes to weather, size definitely matters.